Welcome back, and in this section we are going to work on question 4, Physical Sciences Paper 1, DBE 2022. This question is coming from the topic on mechanics, momentum and impulse. Question 4.1 reads as follows. What is meant by an isolated system in physics? So there are two words that constitute the question here: isolated and system. So first of all we need to know what is a system. So a system is basically anything that we are investigating when we are solving a problem. Okay, so we can just say here a system is not part of the question. I'm just giving a background, a definition, so that we understand what we mean by an isolated system. So a system is defined as a small part of space in environment, part of space in an environment. And we are studying that part. We are considering when we are investigating and solving a particular problem. So that's a system. So anything that we are considering, anything that we are investigating is defined as a system. So it's a small space in an environment, and we are considering, in this case, we are studying the mechanics of 1, the toy cart, and then 2, the rocket. So those are the components that we are considering. So they constitute a system, anything that we are studying if we are to solve a particular problem. So now when we talk about an isolated system, now there are two types of system. There's what is called an open system and a closed system. A closed system is also referred to as an isolated system. So this system it is also referred to as an closed system. Okay, so to define an isolated system, so to answer that question, therefore an isolated system, okay, is a system. So we have defined what is a system here. So it is a system on which the net external force is 0. Okay, so that is the definition of an isolated system. So to answer 4.1, you have to explain it as an isolated system is a system on which the net external force is 0. In other words, there are no external forces that are acting on it. Okay, and let's edit that one. You can edit. That is, there are no external forces that are acting on it. Okay. External forces are forces like applied force, frictional force, and so on. So when we are studying, there will be no external forces that are acting on the system. Okay, so we call it a closed system or an isolated system. Okay, let's come to the next part of the question, which constitutes the largest part of the body of the question here. It reads as follows: during an experiment, a rocket of unknown mass is mounted on a toy of mass 20 kg. So we are given some information here. A toy cut of 20 kg. A cut rocket combination moves at a constant speed of 2.5 meters along a horizontal floor. At a certain instant, the rocket is fired horizontally in the direction of motion at a speed of 30 meters per second. As a result, the cut slows down to a speed of 0.6 meters as shown in the diagram. So we are given the information here. So use relevant physics principles to explain why the firing of the rocket will slow down the cut. Now, the principle that works here, the physics principle that works here is Newton 3. Okay, Newton's third law of motion. Actually, Newton's third law of motion says that when two objects interact, when two objects interact on each other, so when two objects interact on each other, okay, on each other, they exert an equal force in opposite direction on each other. Okay, on each other. So that's what Newton's third law says. Or some put it as when one body exerts a force on a second body, the second body exerts a force of equal magnitude in the opposite direction on the first body. So if we are going to answer this question, we can answer it as follows. So now we want to explain it in terms of what is happening here. So we can say that when the toy car, so when the toy cut exerts a force on the missile, what is that one? Is it a missile rocket? Okay, when the toy cut exerts a force on the rocket, so what will happen is the rocket exerts a force of equal magnitude. Magnitude simply means the size, okay, of equal magnitude in the opposite direction. On the toy cut. So you can put your answer as that. So when the toy cut exerts a force on the rocket, so the rocket will exert a force of equal magnitude in the opposite. So this is just similar to Newton's theory, but we are just putting specific terms here now. So what Newton is saying here is that when the toy cut fires, so the gases that are exploding to push the rocket to the right, in this case the rocket is moving to the right, so the gases that are pushing the rocket to the right, that force will equally push the toy cut to the left, and the forces are equal. If this is force A, let's say force of the rocket, it will be equal to the negative of the force of the toy cut. So they are equal and act in opposite direction. Okay, so that's why now the push to the left will somehow reduce the velocity of the toy cart. So you present your answer like that. Okay, let's go to the next part. This is a short question, 4.3. So 4.3 is reading as follows: calculate the mass of the rocket at the instant the rocket was fired from the toy cart. So we are going to calculate the mass of the rocket. So we are given the mass of the car is 20 kg. So we don't know the mass of the rocket. So the principle that applies here is what we call the principle of conservation of momentum. Okay. 4.3. We call it the principle of conservation of momentum. The principle of conservation of momentum states that in an isolated system, that's why they asked us a question on isolated system, which means if there are no external forces acting on the system, in an isolated system, the total linear momentum is conserved. The total linear momentum is conserved. Okay. Some texts say that the total linear momentum is constant, which means it does not change. Okay, so this is the principle. In symbols, we usually write this as the sum of the initial momentum, sum of pi, p stands for momentum. This is equal to sum of the final momentum. Now we know that momentum is defined as P is defined as the product of the mass of an object and the velocity of the object. So when we say the total linear momentum, here we have got two objects that are interacting, the toy cart and the rocket. So the total momentum of the toy cart and the rocket before it was fired, before the firing, the total momentum will be equal to that momentum will be equal to the total momentum after the firing. Now, if we are going to write this as a formula, okay, we write it as M1 V1I plus M2 V2I is equal to M1 V1 final plus M2 V2 final. M1 V1, this is the momentum of the first object. We can take this one to the momentum of the rocket, and this is the momentum of the toy cart. Okay, so I is the initial, the total momentum, and then the final momentum. So when we substitute, now we don't know the mass of the rocket. That's what we want to calculate. So let it be M. Okay, initially the rocket is moving at the same speed as the toy cart, 2,5. Okay, so they are all moving at the same velocity. So the mass times 2,5, okay, that is the momentum of the rocket, plus the momentum of the toy cart. The toy cart is 20 kg, as you've seen there. The velocity is also 2,5. Okay, so this is the total momentum before the firing. This will be equal to the total momentum after the firing. So M1 is the mass of the rocket. We don't know it, so it's M, and the velocity of the rocket after firing, that is given as 30 meters per second. Okay, so this is 30 multiplied by 30 plus the total momentum of the toy cart. The mass of the toy cart is still 20 multiplied by the velocity reduced to 0.6. Remember here we are taking, momentum is a vector, so we are taking the right as the positive direction. Okay, let's multiply that one. We'll get 2.5 m plus 25, 2.5 times 20, that is a 50, I guess, yes, 50, which is equal to 30 m, okay, plus this is a 12. We collect like terms. Let's collect the constant terms to the left and the m terms to the right. So we'll get 50 minus, so we have here 50 minus 12. It will be equal to 30 times mass minus 2.5 m. It will separate there. So this is 38 will be equal to 25 m. No, 27.5. Okay, 27.5. So that is 27.5 m. To calculate m, we divide by 27.5 divided by 27.5. So our m will be equal to 38 divided by 27.5. Okay, let's clear that one. Okay, we're just going to change the mode here. That is 38 divided by 27.5. Okay, our answer will be 1.381. So it's 1.381. So therefore, the mass of the rocket is 1.31 kg. Okay, that concludes our question. It's 9 marks. Thank you for watching. We'll see you in the next video. Bye.